Okay, so we have the equation. X squared plus 5x plus 6 equals 0. Now, if you give people this equation and they haven't seen quadratic functions before, know anything about the quadratic formula, which is what we're going to talk about today, they'll try to put all the x's on one side and then all the numbers on the other side, but they'll end up maybe with an x squared on this side and an x on this side. What you do with linear equations isn't going to work in this case, okay? It just isn't going to work. Now, I threw this out and people, spontaneously did this. I said, okay, that's x plus 2 times x plus 3 equals 0. Now, think about it. Is there a number we could substitute for x that would make this 0? So if you're viewing this, stop and think. What number could we put in for x? There are actually two possible numbers we could put in for x that would give us 0 from this expression. So you should stop the video and go on. Now, we've already posed this problem in class, so I'm going to go ahead and give you the answer, but I hope you've thought about it, okay? X equals -2, then we get -2 plus 2 times -2 plus 3 equals 0. -2 plus 2 is 0. And -2 plus 3 happens to be 1, but it really doesn't matter what this one is. As soon as we know that this one's 0, we know we're going to be multiplying by 0, and we're going to get 0 equals 0. Okay. So I said there were two numbers. What's the other one? What other value of x will yield the equation 0 equals 0? So what other value of x would be a solution? Okay, so we got an answer. Well, if x is -3, you get -3 plus 3 here. So just let x equal -3. Okay. Just substituting -3 for x, we get this. And so we have -1 times 0 equals 0. Okay, so our solutions. And I'm going to call this a solution set. It's a set of numbers, -2, -3. Just to double check. Go back to the original expression. That x squared plus 5x plus 6 would equal what? Well, it would equal -2 squared plus 5 times -2 plus 6. And that would equal square of -2, you get 4. 5 times -2 is -10. Add 6. Well, all that adds up to 0. So that checks -2. And if x is -3, then x squared plus 5x plus 6 is -3. squared plus 5 times -3 plus 6. And that equals 9 minus 15 plus 6, which equals 0. That checks, so we've checked this. I should have used a separation instead of parentheses there. Okay? So one way to solve an equation like this is to factor it. Now, there are many equations, most equations you can't factor. They're just, it's not possible. Because actually most equations give you what's called irrational numbers. So let's look at this equation. X squared plus 5x plus 7 equals 0. Now, I'm just going to tell you, I know we can't factor this, not because I've tried to factor it and can't, that doesn't prove anything. Okay, just because I can't factor it doesn't mean it doesn't factor, okay? But in this case, it doesn't factor over real numbers or even over fractions. There's a formula that I'll give you. I'll just show you how it works out. There's a formula I'm going to give you that tells you that the solutions are these. And we'll work with this formula quite a bit here in a little while. So if I do the arithmetic inside the parentheses, I get -5 plus or minus the square root of 25 minus 28, all divided by 2. And the kicker is I get 25 minus 28 is -3, so I end up having the square root of -3. Now, what's the square root of -3? Well, let me just kind of put that up here. Square root of -3 equals the square root of 3 times the square root of -1. Now, we saw this last time, okay? The square root of -1 is I. That's our definition of I. So this isn't even a real number. So what we get down here -5 plus or minus the square root of 3 times I divided by 2. And we can distribute the division. The -5 is divided by 2, so is the square root of 3I divided by 2. So we get this as a sum of 2 terms. And our solution set is then two results that we get. One if we use the plus, the other if we use the minus of this plus or minus. Well, that's a lot to digest. So what we're gonna do is we're just gonna evaluate another expression. Okay. Suppose we've got an equation that gives us x equals 4 plus or minus the square root of 49 minus 20. And all that over 2. Can you simplify this the way I've simplified this? You're going to end up with a number plus or minus some square root, all that divided by 2. So it's going to look a lot like this. So this step looks like this. What do we do for the next step? What did I do between here and here? What are you going to do with this? Okay, so step is pretty obvious and everybody did that really well. We got 4 plus or minus the square root of 29 divided by 2. Okay, now in this case, this number isn't negative, is it? Square root of 29. Okay. Here we had a negative and we had to factor out the -1 so we'd get an I when we do the square root. But that's not going to happen here because we don't have a negative. Okay. So we don't have to worry about this in this case. If it was 49 minus, let's say, 60, then we'd have a -11 here and we have to worry about I. But if we don't have a negative here, it means we have real solutions. Okay. So let's not worry about this step or this step, but what now did I do between this step and this step? What happens between here and here? Okay. So what I did here, I did go to a calculator and punch this number in. We can do that at any time, but right now we want to get the exact solution. The calculator will give you 8, 10, 12 digits of this square root, but it's not going to give you the accurate square root. It'll be very accurate, but it's not going to be exact. So it's not going to give you the exact square root. Okay. What did I do down here to get from this step to this step? What's different here than here? Well, I've got the -5 over 2, and I got the -3i over 2, right? Just like a distributive law. It is a distributive law, but for division, division by 2 distributes over an addition or subtraction. So what we can write is, this is 4 over 2 plus or minus square root of 29 over 2. That makes sense? Okay, then of course 4 is an even number, so I know I can divide it by 2. That's going to be 2 plus or minus the square root of 29 over 2. Your solution set is 2 plus the square root of 29 over 2 minus square root of 29 over 2. So that's how we would simplify this expression. Okay, now I'm gonna write the quadratic formula. And then we're gonna see where all this comes from. So quadratic formula, first of all, says this: if ax squared plus bx plus c equals 0, then x equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. And it's usually not stated this way, but it's real important logically to be sure we understand that there are no other solutions. If there are any, well, there are solutions. Maybe they're real and maybe they're complex, because we could get an expression like this that gives us a complex number with I on it. We could have it like this where we get two numbers that are real, even though they're irrational. And we'll talk a little bit more what we mean by irrational. Okay, so try this. Let's just, first of all, let's reconstruct this. Okay, so let's say that we've got 3x squared plus 9x minus 4 equals 0. In order to apply the quadratic formula, we have to identify the numbers a, b, and c. The first thing we do is write out a equals and then b equals and then c equals. In other words, we want to identify a, b, and c. So my question is, can you tell me what a is? Okay, so okay, very good. Now, one thing that people often do, so if you did this, don't feel badly. They want to say that, okay, well, there's a, so a is 3x squared. Well, that's close. You identified it, you're looking at the right thing, but notice that a is a number in front of x squared. It doesn't include x squared, okay? So a is just 3, the number in front of x squared. B is 9, it's the number in front of x. And c is the number that doesn't have any x's. And in this case, c is negative 4. Okay, so once you see how to identify these, I don't think everybody here did that quite well, except for some people throw on the x squared or the x, but you don't want to do that. Makes things a lot more complicated if you do and you don't get the right answer. Okay. Okay, now we want to plug that into this formula. Okay. So we write x equals, and then we put a, b, and c in wherever they belong. Okay, we did well with that. Okay. X is what? First of all, you have negative b. Well, b is 9. So we're going to write a negative 9. Let's write the plus or minus square root in the fraction bar. It's going to be plus or minus then b squared, which is 9 squared. Now, I'm going to recommend that you put parentheses around what you're squaring, because it's very easy if B happened to be -9, you would write -9 squared without the parentheses, and you'd end up with the wrong answer, okay? You need parentheses, so I say always put parentheses around the thing you're squaring here. Even though it's not necessary when you're doing 9, it is necessary if you were doing -9. Okay, so now remember, this B has a negative on it, and this B is squared, and there's no negative involved. Okay, unless B itself has a negative. Then we do -4AC, well, that's -4. A is 3. And C is -4. And then this is all over 2A, which would be 2 times 3. And there we've written it down carefully. We've got every number in the right place. And now we can just do the arithmetic. We can simplify the arithmetic inside the parentheses. And we can multiply 2 by 3. Okay, so go ahead and see what we get. And don't do the square root at this point. We'll do it in a minute, but write it without taking the square root. In other words, keep the radical sign there. Okay, so we did real well there. The -9, we're not going to do any arithmetic on the -9 yet. Now 9 squared is 81. And 4 times 3 is 12, and 12 times -4 is -48, but we got a minus here, so it's plus 48. And 2 times 3 is 6. So this equals -9 plus or minus the square root of 129 over 6. Okay. Now, you'd want to do a prime factorization of 129 or identify the biggest perfect square within 129. Because that's what we do with radicals. Well, 3 goes into 129. It goes into 43 times, and 43 is a prime number. So 129 is 3 times 43, and it doesn't break down any further. So there's no perfect square here to factor out. We have the -9 over 6, and that reduces because 9 is 3 times 3, and 6 is 2 times 3. So we end up with, well, okay. I'm doing too much in one step. Let's just carefully write out the next step here. Okay, well, this equals -9 over 6 plus or minus the square root of 129 over 6. That -9 over 6 reduces down to -3/2. And the 129 is also divided by 6, as it was here. So there it is. And now we can write the solution set. And my arrow hit it up so long I don't have room to write it out. Let's go ahead and do this, and then we have, okay, -3/2 plus 129 square root of 129 over 6, negative 3 halves minus the square root of 129 over 6. Okay. And if we've done it correctly, then if we plug either of these numbers in here, we're going to get 0. Now let's just make sure we see that our calculator is not going to give us an exact solution, okay? So why don't you take your calculator and evaluate negative 3 halves plus the square root of 129 over 6. See what decimal number you come up with. Okay, and I calculated that with the plus here, it would have come out 0.39. With the minus here, it came out negative 3.39, and that's what we got when the class did it, okay, because people did the minus. So let's go ahead and write out both exact solutions. That's approximately equal to 0.39. Now, actually, let's look at what we got on a calculator. Okay, well, right there is the number that comes out on a calculator. Probably isn't real clear because the camera's still focused on the screen, but I'll write it down for you. This one would have been negative 3.392969. Seems like every other digit's a 9, but that doesn't continue. 4, 5. That's 1, 2, 3, 4, 5, 6, 7, 8, 9 significant figures. Now that's pretty accurate. But if we plug this number into this equation, it's not really going to give us 0. It's going to give us a very small number, but it's not going to be 0. If you plug my mental calculation, 0.39 or negative 3.39 into the equation, it's not going to be 0. It's going to be a pretty small number, not nearly as small as it'll be if we plug this in. Okay, so let me ask you, the better the calculator here to plug in this number, negative 3.39296945 in for x. So you're going to have to square it and multiply it by 3. Then multiply it by 9 and add to what you got here, and then subtract 4. Okay, well, we're having some glitches. Some people having glitches getting this whole calculation into the calculator. But point is, if I plug in this number, make sure we see the decimal on that, into this expression for x, we're going to get a number that's close to 0, but not exactly 0. Okay, so no matter how many digits your calculator gives you on this calculation, the left-hand side isn't going to be exactly 0. On the other hand, if you plug in this expression and do all the algebra, you will get exactly 0. Now, I'm not going to do that. That's more algebra than we're going to be able to really deal with at this point of the course. Still, it's important stuff, and you might have to deal with that in a pre-calculus course, which is one reason that this course leads into the pre-calculus with the support course and not just into a straight pre-calculus course. Trying to give you as much intermediate algebra as possible with the goal of passing the pre-calculus with a 3-credit support course. In the support course, we'll fill in some of the blanks that we haven't been able to fill in this course. Okay. So anyhow, that's how you use the quadratic formula. Okay, that's pretty much what you need to know at this point. Now, you can apply the quadratic formula and the results of the quadratic formula to the graph of the quadratic expression, but we're not going to get into graphing quadratic expressions in this course. It's kind of unfortunate, but you get that in pre-calculus again. Do it with a support course. We should be able to give you enough to get through it. Okay, so we can't plug that big long number in because not everybody knows how to use the memory function of their calculator. And we don't have time to deal with that at this point, but we can do this. And I can ask people to do the calculation with their calculator. So if we plug this in, we have 3x squared plus 9x minus 4 equals 0. That becomes 3 times negative 3.39 squared plus 9 times negative 3.39 minus 4 equals 0. Now, can you do 3? First square this and then multiply it by 3. Let me ask the class to do that, and let's see what number we get. Okay, so the calculator gives us 34.4763 for 3 times negative 3.39 squared. We normally store that in memory. Then we multiply this, which gives us negative 30.51, and store that in memory, add it to this, and then minus 4. Now notice that 30.51, negative 30.51 minus 4 is negative 34.51. And this is 34.47, 0.4763. So what we get here is going to be 0.0463 equals 0. Is that right? No. 47. Yeah. Okay. Anyhow, I might have screwed that up, but we get a small number equals 0, but it isn't 0 equals 0. Okay. Even though this is an accurate solution to two significant figures, the real is negative 3.39, not the real solution, but the more accurate solution is negative 3.3929. Now that rounds off to 3.39, but got all these other decimal places, and all numbers in all those other decimal places will reduce this result by quite a bit. Okay, and we'll get a lot of zeros and then some digits equal to 0. Okay. Just to emphasize what I said before, if we put the exact solution, we would get something like this. We get 3 times negative 3 halves minus the square root of 129 over 6 squared plus 9 times negative 3 halves minus the square root of 129 over 6 minus 4 equals 0. Okay, if we do the algebra to expand this with the radicals and so forth, it'll give us exactly 0. Okay, all this stuff will simplify down to something that where everything cancels everything out and we get 0. Now, if your algebra is up to it, you ought to go ahead and see if you can do that. We've done all the algebra, distributive law, squaring things and so forth, but still, it's kind of messy. So I don't recommend that you spend a lot of time on that at this point. Unless you got everything else done really well. Okay, now we're gonna see if we can identify A, B, and C, just like we did before, for this equation. And then plug it into the quadratic formula and simplify it. And then if we have time, let's see if we can do this one. Okay, I think we did pretty well on this one, got it done pretty quickly also. This one is going to give us x equals -5, not -5x because it's the number in front of x, right? Plus or minus square root of parentheses -5 squared. Remember I said here, always put parentheses around this number, whether it's positive or negative. You don't really need it if the number is positive, but you do need it if the number is negative. So you put the square of -5, and then it's -4 times A, which is 2, times C, which is 1. Then it's over 2A, or is it 2 times A, which is 2 times 1. Now, I didn't leave myself much room, but there's the expression, and then it simplifies. Okay? Now, we're about out of time, but let's see, we've got 2 minutes. Let's see if we can write out the expression for this one. Just a quick note, I took a quick look at this. Something didn't feel right about this. I felt like I should be subtracting and I just got messed up in my head. I believe that should be -0.0337. I haven't double checked that. If you look at my previous answer and think a little bit, you can see what kind of a bonehead mistake I made. Okay, so doesn't matter. The whole principle here is simply that this is real close to 0, but maybe not close enough, depending on what we want to do with the solution of that equation. And this is exact, and it can always be evaluated to any number of decimal places that we and our machinery have time to generate.